The appliance industry is stuck in this spot where like they really need to charge people for repair and servicing and all this other stuff. They're not going to go out of their way to like help fix your stove and keep it operating. If you flip the script where it's like, oh, it's actually in the interest of us and the brands to make sure that every appliance is just rock solid and works forever. That's a very different value proposition for the consumer, because they know like if my stove goes down, like they'll give me a new one.
Sam, it's great to talk with you today. Let's start off with who is like the chef in your home as a kid?
So both my parents actually cooked a lot. And it's kind of a funny thing is I remember making waffles with my dad as a kid, doing barbecue. I was not allowed to deep fry a turkey, but we did.
Did you guys have that conveation?
We did deep fry a turkey. I mean, it was more like just don't go near the turkey fryer and it's sort of thing like that. But deep fried turkey is amazing. Yeah, like ended up cooking a bunch of stuff like while I was at home with my parents and stuff like that. So it was always like accessible. My uncle actually owned a restaurant until very recently.
Yeah.
So there was like some of that DNA in the family. One of my cousins, trained professional chef. You know, there's kind of like that sort of stuff has been around, and like, you know, we weren't, and of course, like my mom's always been like judgmental of other people's cooking, and you know, being like, oh, this potluck was terrible, like, you know, sort of thing like that. Second piece was always like to kind of go travel and try different types of food, and that really started heating up, honestly, as part of being in hardware companies. Because what do you have to do when you design consumer products? You got to go meet people for dinner in China a lot of the time, and among other places. So like China, Japan, South Korea, Taiwan, Hong Kong, Singapore, like you name it. Ended up having to go. I spent probably I spent a quarter of the year, 1 year, literally like just in China, in 2015 or 2016, and like it was at the level where Facebook at the time got me a residence permit so that we
for China?
For China.
No way.
So that we wouldn't get in trouble on it from a compliance standpoint, because technically once you cross 90 days, you're like
not a citizen, but you're
you're past the point of like they need to know about you for tax accounting purposes, basically. And they were trying to play by the book. If you're just like a startup person, like doesn't really matter. But like Facebook obviously was trying to get into China at that time, like it was 2015 or something like that. And so it's funny is like basically we just spent tons of time out of home, like not at home, but really loved like street food, trying new stuff, trying to tell people like, hey, does this have peanuts in it or not? Because I have a peanut allergy.
Did you have a carry those like EpiPens
and stuff like that? I tell people I do.
But are you living on the edge?
No, I carry a bunch of Benadryl with me in my backpack. So I usually, and I do have an EpiPen in my backpack, but may be expired. Who knows? Those things are expensive. But
that would be a crazy bear case. He died of a peanut allergy.
So the good thing is my allergy is pretty minor. So it's like I can deal with it with like 2 Benadryls. But one thing was for certain though, is like I really liked like taking some of the food I had in, you know, basically like side of the road in Shanghai or whatever at like 2 a.m. after me and some friends were at a bar or whatever, eat some like lamb skewers and like this grilled bread thing they have that's really good and all this other stuff. And I was like, can I cook that at home? And so I really got into like, hey, I'll get like the right barbecue grill. I'll get the right equipment.
What was the grill that you
got? One of these like skewer grills that's like a little trough thing that you can like barbecue on. And if you come to my house ever, I still have that. It's great. You make lamb skewers and stuff like that. It's super, super, super good. So I just kind of got into the craft of like, hey, I really like this thing. Let me go and figure out how to replicate it at home. Not really a professional chef thing. Not anything like super serious, but right before the pandemic, this kind of actually, I started getting obsessed about other things. I was like, could I make a pizza really fast? And I was like,
did you get one of those like little pizza ovens?
Well, so this was like right when those companies were, I think, getting started. And I was thinking, could you make a tabletop plug-in electric version of this?
It makes it in like a minute.
That would make it in like a minute. And I realized this was a fundamentally power limited task. It was something that like you could not pull from a 120 volt plug the power needed to flash cook a pizza, basically. Because like the radiation from a brick oven and like also conduction from the stone is like, that's more power than what you'd normally get. And
Is it more than like just goes to a house kind of thing?
yeah, it's
Yeah.
you'd have to store and deploy the energy basically, which it's not more than what goes to a house, but it's more than goes to a 120 volt just normal plug, which would be like 1500 watts or something like that. And for comparison, I actually, when that happened, I went and looked at other kind of like smart oven products that are about 1500 watts, like they run off a plug, and I was like, do they advertise that they can cook a pizza? And I found out it's like 10 minutes. And I was like,
Those are rookie numbers.
That's rookie numbers, but it's fundamentally not the same taste profile because you're not cooking it in the same way. And this sent me down this rabbit hole, and I was like, but what if you added a battery to the pizza oven? Because then you could trickle charge the battery from whatever's available, like you can 120 volt plug or solar panel or whatever you want. And then when you need to cook a pizza, you just press the button and it dumps the battery power into the oven. And I was like, this seems like a good idea. And I actually went and started buying some of the parts to go and build this. And I think it was like 2018 or 2019. And like, I just totally was too busy with work and other stuff to like.
Yeah, you were like working at Facebook.
I was working at Facebook at the time.
Like,
Yeah. And so we were designing a next gen controller that shipped with the Quest Pro headset. So it was like a computer vision on the controller. It was kind of a cool product. But I went and actually bought like an LFP pack and all this other stuff. And it was like, I probably could have banged out a prototype in a couple weekends, but I didn't end up doing that. But then I realized that this was a bigger idea. And it was, if you could make better appliances because you put a battery in them. So the whole idea is like the energy from the wall is a power supply from the wall is limited. Even if you're on 240, like you may have to rewire your house to install an electric vehicle charger.
Yeah.
Like you may need to get a new service connection on your street, basically. They may have to even upgrade the transformer on the pole to be able to.
Basically the like residential houses are designed for a very small amount of energy.
They were designed for a past era, and we've like decided to make the built world really hard to change for various reasons, like, to preserve our parents' housing prices or whatever. And so you're not interviewing me about the book Abundance, so we can talk about that maybe on another podcast. But basically, basically the point is we've frozen the built world in amber. It's really complicated to change stuff, and at the same time, there is this transition happening, and you can call it like, climate-driven energy transition or whatever, but it's really like there is a transition to a new technology stack. And that new technology stack is kind of like what I would loosely call like the electrification stack. And it's not honestly, the argument like is less and less about like, is this a climate change thing? Are we saving the planet? So no, it's like, this is just better and more powerful and more awesome.
It's just better tech.
And this came from the EV industry, basically getting all this stuff to kind of escape velocity, where now you've got batteries, you've got advanced power electronics, so you can actually deploy that energy like at high power and high power density. And then you've also got like motors as well. So like, everyone's talking about robots and robot actuators these days, but like where that come from, where a lot of that oomph come from, it's like the EV industry. And then lastly, it's like obviously computing as well. So it's basically like all the tech inside your phone plus all the tech inside your electric car. Well, that's the same stuff that's in a drone. That's the same stuff that's in pretty much all of these like new class of devices. And it's coincidentally all in the same stuff that when people start freaking out about like, oh, China's beating us in XYZ, they're beating us at that.
Yeah.
Because that is the technology stack of the future. It's not a like, oh, we're going to make the tanks woke by making them series hybrids. No, the tanks are going to be better and they'll be quiet and they will have lower thermal signatures, and
they'll go 0 to 60 and whatever.
And they'll have better acceleration, and you'll have all this energy available to like for electronic warfare and air defense and all this other fun stuff. So like, and lasers or whatever you want. And so, and that's kind of an extreme example, but basically that transition is happening. And meanwhile, the built world is frozen in amber. And so there's this actually opens a really big opportunity, which is like kind of going back to that pizza oven. What if you could make just fundamentally better devices that people will buy anyways, because they give them a capability that they would not otherwise have? They put them in their house, and then coincidentally, they've installed a battery.
Yep.
Now, you don't need to upgrade all of that infrastructure upstream of that battery, because the battery can choose when to draw energy when utilization of that whole delivery network is at its lowest.
You're basically not, you're choosing a different path instead of like trying to fight regulators and do all this other stuff. You're just like, why don't we just make it so we have this, portable thing that every single house can have. And
yeah, it's not necessarily portable, right? So it's
Right.
like, it's not necessarily a portable thing, but it's a like appliances are installed in every neighborhood in the United States every day of every week out of the month, every week out of the year. So it's like, and so kind of like bringing it back to like the big picture, it's like, so there's this pizza oven concept I'm like obsessed about. I take a step back and I'm like, is this a more generic idea? Like, can you do this for kind of any device with a power cord? And what are the most exciting ones? And then I realized, what about other home appliances? They're permanently installed. So like, again, the battery would then be permanently installed in the house, which means you can do more than just like power the device with the battery.
Power the house.
You can power the house. You can power the grid.
Yeah.
You can power the building for multifamily. You're able to do things because it's installed that you wouldn't otherwise be able to do. And then the last piece was like, okay, so what do we do first, right? And it's kind of this funky thing where it's like, I believe we're making kind of like this play at the tech stack of the future, but we're making a stove, right? It's kind of this funny, like, it's like, okay, that's a weird thing to do. Very few people are doing that. There was a couple smart oven companies a couple years ago. I mean, some of the product experience in those is fantastic, by the way, but it's like, this has been a space where there are carcasses like Juicero. The appliance space is not for the,
there's just some horror stories.
It's not an enterprise SaaS like play where there's like, it's a straightforward thing for some VC analyst to be like, yeah, this thing rocks. You meet these metrics, we'll lead your Series A. Like, it's not that. It's not that. And so it's a little psychotic to go into this space, especially given like, oh, there's like, and also, by the way, it's also kind of consumer hardware, right? Consumer hardware is psychotic as well. I have friends who have crazy revenue numbers, and even then, fundraising is not some like you're anointed, walk in the park, anything like that. Like this is not. This is a little bit of a there be dragon situation, even though more people should be doing this, because I think if more people do this, the investors will realize this is actually a good space to be in, and it's actually much better than enterprise.
So it's your job a little bit to
my job is
pitch,
to prove that
this is like an awesome quest, and we're going to go on it together if you want to be on.
And by the way, other people I think should be starting hardware companies, because I think if there's more of us, I think this is going to be something where at least more VC funds will have templates to show that this is like a reasonable investment, versus a psychotic side quest, basically. Yeah, so that kind of gets to like why a stove, right? And so we wanted to I basically was like, what is the one thing in your house where the fuel source is the user experience?
And that's the stove.
Yeah. Well, it's a gas stove. In a case of a gas stove,
I want to also talk about that, because like I know if I come from like a chef. I actually went to like chef school, and if you asked most chefs like what they want, they would basically respond with, in effect, a faster horse, right? A better, like more precise gas stove. And then you come in and you're saying, well, this piece of technology that used to be bad, which was like electric, where it would go on and off constantly, and it wasn't super precise, like you can make it amazingly precise. How did that work?
Yeah, so it's actually interesting of like, I was always kind of a gadget nerd, sort of like I would follow the happenings of, what people were shipping in kind of the smart appliance space and other things, and like would obviously buy stuff if it kind of nerds sniped me.
Do you have any examples of things that you bought?
The first, I didn't want to buy it until I had some venture money for this idea, but I was like, I need to get the Breville Control Freak. And so the Breville Control Freak it was designed by this company, I think it's Polyscience. So Polyscience they're like the original like sous vide people, basically. And I think they started with like, it's literally for like temperature processing for science experiments, basically, and biology and stuff like that. But they basically started a cooking division. And then they were shipping, I think, a sous vide circulator, because they were doing immersion circulators for like biology research and stuff like that. And then they made a hot plate, so like a single burner induction stove, basically put on your counter, that had a temperature probe on it. So it would actually sense the bottom of the pan through this contact sensor, And it worked pretty well. So it's like you could actually put a pan on there instead of saying 0 through 10, and you have no idea what 10 means, you can say 350 degrees and it will hold it. And it works okay. It's a pretty good product. And I was like, I wanted this thing because it was like, in some sense, that was what all induction stoves should have. Like, why are you running this like what's called like open loop control, where you're just setting a power level and not understanding what the pan's doing? And that's how cooking works, right? Like you have to look and you have to like lift the pan up and do all this other stuff. And like that's where you went to school for, right? So so you end up in this thing where the temperature control is like, if I was to stack rank the automations you would want for a kitchen gadget, it's like if I took your oven's thermostat away, would you want to use that oven anymore?
Yeah, and it's also funny because people like brought these like laser pointers to check the temperature. Right?
That's how we verify that.
Yeah.
That's how we. It's not a laser. It's the laser is actually the laser is actually just showing you where it's aimed at, but it's an infrared sensor that for the audience. And so
you probably definitely know more about this than I do.
We had to tear down and study every single way that people have done this before we narrowed it on to approach.
How many people have done this or tried?
So I mean, there's been a bunch of companies have done temperature controlled cooking. Breville or Polyscience, which then sold their cooking division to Breville, did the best, I think, up to this point. And it was just a well-tuned kind of standard control loop where it's like measure the sensor, update the induction power level to try to keep the pan at a specific temperature, and they didn't do anything super sophisticated. Some other brands do something where they have an infrared sensor going through the glass. The problem is the glass blocks like wavelengths of infrared light below a certain temperature. So it's like it only works at 300 degrees plus. So you can't sous vide on it or anything like that. And also you get signals from the glass and other stuff. So it's not perfect. And then there's this other category of devices. You buy special pans and they have Bluetooth and they have a thermocouple like threaded into the very bottom of the pan. And those actually can work pretty well. The issue is I'm not in the pan business, I'm in the stove business, right? So company Heston, we've got some folks from there actually with us, but this company Heston, interestingly, like they sell pans. So they went down that approach, and that's a good idea if you're selling pans, right? So the idea that we had though was we want to make sure you install this thing in your house and like you don't have to replace your pans or do anything special. And we also don't have to fight like, oh, you can't use this fancy pan brand. You could just be able to bring your own thing. But then the second thing we found out was like none of these approaches worked at high power at all.
Why?
So this kind of comes into a speed situation. So it's like if your induction system heats the pan faster, the sensor has to respond proportionally faster, or you could end up in a situation where it will be hot before it knows it's hot.
Oh, so you're just burning stuff.
And you'll burn stuff, or you'll overheat the oil and start smoking, or in a more extreme case, you'll actually like warp the pan. Like there's a number of issues there. So we were like, we needed some different approach because the other piece of this, and again, I'm telling the story in such a long form way. So my apologies for meandering.
No, I love it.
I'm meandering a bit. We put a battery in the stove. The battery gives us like 15 kilowatts of additional power beyond what the plug gives you. So I was like, let's make this thing output 10,000 watts. If you want to steer 10,000 watts to a single burner, go for it. And that's 3 times more than like a typical induction stove when it's in its power boost mode or whatever. Like, and that's enough, if you haven't heard me say this, to boil a liter of cold water from the tap in under 40 seconds, or 10 cups in like, I don't know, it's like a minute and a half or something like that. So it's very quick. Like you won't have to wait for pasta or anything like that. You potentially can put the pasta in cold water.
And isn't your goal basically to like, you put the pan on the stove and then by the time, you turn it on and by the time you come back with whatever ingredient, pasta or whatever, it's
like
ready
there's
to
no,
go.
There's no lag. There's no lag.
Yeah.
And then, the problem is if you have that, you need a sensor that is fast enough to track that rise in temperature. So we had to invent a new sensor type. And we actually, the first thing we did, we were like, okay, let's take the sensor design from the Breville Control Freak, which is it's like a thermistor way of measuring temperature electronically. It's basically a resistor you run current through and it changes if it's a different temperature. And then you have that touch the bottom of the pan with a little metal cap and some industrial design work and stuff like that. So you had that. And then we're like, well, that's too slow because you don't control that, like that contact.
Yep.
And then we were like, okay, let's also do the optical thing. So let's throw the optical thing on as well. And then we found a bunch of issues with the optical approach and so we're like, okay, we could do some like combine this thing, but it's not measuring what we want. What we want to measure is not the bottom of the pan. We want to measure inside the pan. We want to measure what you're actually cooking.
Exactly.
And
like the surface temperature of the pan.
The surface temperature of the pan.
Yeah.
And that's a different thing to measure. It's a very hard thing to measure. And
how long is this process of just like realizing, oh crap, there's just, whatever, path we go down, it's just not quite the right one. And you got to go down.
So we actually, we narrowed that tech, that the research kind of figuring out the architecture there took almost a year from kind of fresh start of the company.
It's like 2021 to 2022.
Yeah, 2021 to 2022. And we hired an external consulting firm and kind of like just boiled the ocean on all the approaches. And they were like, they ran a bunch of experiments with different things. And it's pretty cool, pretty cool set of prototypes we ended up building about that. And it was interesting. And then you had to develop algorithms around that, do all this MATLAB stuff. It gets really messy.
This was before Claude.
Before you could vibe code anything. And
right.
So basically, we got that figured out. Like I remember getting a demo of our temperature control system in like August 2022, and I think they cooked me like an egg. They made me like a McMuffin or something. I forget the exact thing they made me. It was actually quite good. The prototype was not a real prototype. It was like this like hacked up thing that they built.
But you're like, it works.
It works, and I understood the physical principles. I'm like, this is actually going to work. Like this will actually work. Now, then it took us another year to get prototypes yielded from our manufacturing partner with the like ceramic components, the custom ceramic components, and like all of the optimization we had to figure out. We had to make sure that like the spring that pushes it into the pan wasn't magnetic, so it didn't like itself melt or anything like that. Like there was crazy stuff we had to engineer in that system down to like the component level to actually get that out. And so we pushed that through our supply chain and eventually yielded out a first version of that sensor that was like production grade. And there was a bunch of intermediate lab prototypes we did internally.
Did you melt any like stoves at one point?
We've melted sensors before, but we've not actually caught a stove on fire.
Nice.
And the sensor melting is like, a lot of it's basically, the easiest material to make the sensor out of is plastic, because you need to like mold it. You can make it out of ceramics and stuff like that, but that gets really complicated.
It'll take time.
It takes time, and there's process development. We didn't know the vendors and all that sort of stuff. But there are plastics that are rated to very high temperatures, like well above what you'd ever need to sear a steak at. And so we're like, let's just use those. And then you have to figure out, okay, what's the intersection of the plastics you can use, their actual melting points, their rated melting points, because the rated one is what you're allowed to like set the stove's max temperature to. And like this turns into an entire design challenge of like, what plastic resins can I get that are already certified so I don't have to recertify a new one for like fire risk or anything like that?
Yeah, just add extra time.
And add extra time to like all those stuff. So it ended up being a very complicated challenge that a number of really talented folks on our team like address kind of like cross-functionally to actually make this thing both work and be manufacturable and be high enough temperature rated that like even if like some arbitrary like temperature overshoot situation, it doesn't melt itself. And that took, I think I was like going through the number of discrete, like for the whole stove program, it's like we basically built like, I should actually walk through the number of prototypes we had to make.
Let's do this.
Yeah. So
and also walk through with the timeline, like what date?
What date? Yeah.
Around which?
Right. Yeah. So for grounding this, like I come from the consumer electronics industry. I was at Facebook, Google more recently. Yeah. And so that, but typically you have like a standardized product development process. Now the appliance industry actually works a little differently than this. It's much more of we'll build some prototypes, then we'll ship it.
Is it because they're just like not that complex or something?
It's because actually it's interesting. It's not like they're not very complex. They're actually very complex in you have 100 different SKUs you have to make. but they all have off-the-shelf electronics from like one or two vendors that like are essentially the suppliers.
So you put them together in a slightly different way and ship it.
It's like building it's like you wouldn't need to do 5 iterations of a desktop PC build where all you were really doing custom was the case.
Yep.
So it's like imagine you're building a desktop computer. You have a sheet metal shop that lets you build whatever case you want, but you're buying your motherboards from Gigabyte and you're buying your GPUs from
NVIDIA or something.
Yeah. So you basically and so you're doing this as like a kit build, but the brand facing parts are all things that you like. That's all it's the enclosure basically, and then. This is the thing in the appliance space that's really tricky is you have to install this in someone's house. Their house could catch on fire. You don't want to be at fault. So you need to get this thing certified. And that's why you see like the UL little circle or CSA or there's a couple other labs as well. You'll see a listing on that thing where it's listed to a specific test standard, typically a UL standard or CSA standard if it's North America. And that process is a big can of worms. But what this means is these appliance companies, they're really good at distribution. They'll have showrooms like literally across the street from here with like
a bunch of different models.
Bunch of different models. Yeah. They'll be in thousands of showrooms across North America. They'll have all that reach. They can handle.
Is it just like a lot like the car industry?
It's like the car industry.
Yeah.
It's very much like the car industry. It's like Ford buys Continental and Bosch parts.
So in like more ways than one, you're kind of trying to be Tesla a little bit.
Yes, actually, that's a good way to put it because but it's Tesla in, I would call it the 2010 sense, not Tesla now is a even different beast, right?
Yeah.
But like the 2010 Tesla was the electrification stack provider for the automotive industry. That's what got their IPO done. That was like the key thing was Daimler and Toyota had deals with them to power their next generation electric vehicles. Tesla was going to build the battery, the inverter, the motors, like the whole powertrain for these guys. And they had all the IP to do it. They had the ability to manufacture it. They had already built the Roadster. They didn't end up doing that because they IPO'd and made enough money and then raised enough money to be able to and they got really lucky in the recession, bought Numi. Like they got super lucky to be able to actually do this direct to consumer CarPlay and manage to grind it out after many painful years. But how were they valued in such a way where after only shipping 1,000 cars, how could they possibly IPO? And it was this. And so I've like studied that very closely and like acutely aware of that reality. So
did you just see like Elon Musk's pain and we're like, that's what I want?
I think there's ways to avoid that. So the big thing is I don't want to run a car factory under any circumstances.
So someone else is like manufacturing it and then you're just like,
well, so no, I think car factory is a different story because just the CapEx of a car factory is just so brutal. It's like you essentially have to be your own GP of your own venture fund to be able to get the capital required to like make some of this stuff happen. And like effectively he kind of is in a sense. But yeah, so going back to, I'm trying to remember the initial part of this tangent journey.
Basically, the timeline for the different iterations.
The timeline for the different iterations. So basically, like, and then I went into the appliance industry being like, cool, buy the off the shelf electronics, integrate it in your box, get it certified because all of those parts are already certified, so it's easier to certify. Yeah. But that means that you have the same parts as your rival, your crosstown rival.
You're selling a slightly different product, but like. Very slightly. It's just the case.
But your advantage is brand, industrial design, and distribution.
Yep.
And service as well. So like you can actually like be like, okay, the reliability and all that other stuff. But that's where people actually hold up these brands versus consumer electronics that different versus a technology play. So on the flip side, we ran this program like a consumer electronics program. And so to describe that, it's kind of like you build prototypes where you're like, let's figure out if the science of the idea works. And like an example of that for the audience would be like Palmer Luckey being like, hey, I got some magnifying glasses I like that I think if I look through this on a phone screen, like I get a good, this is actually, like I'm pretty sure, I may be misquoting kind of some of the origin stories for Oculus, but like essentially it was like, figure out what could be done with the off-the-shelf parts and like almost like duct tape and like
Figure out something that you can just make. And work.
But basically figure out like what is the like get the science project part of it out of the way.
Yeah.
And so the science project part of it for us was like, it was, can you put 10,000 watts into a pan and actually, can you triple the performance of an induction stove?
Was that actually like ever a question of, does this even like work at all?
We were trying to put it in a smaller pan than normal, like a consumer pan, like, because you could totally do like a induction wok burners that are like huge, can do like 8,000 watts or whatever, it's fine. But I was like, was there some fundamental problem with like, hey, I put a small pot on a stove like ours and like throw 10,000 watts into it. Do you get the problem that nuclear reactors get when they go into meltdown? When they go into meltdown, where if a water cooled reactor, where it turns all of the water around the fuel rod into steam, and then it's jacketed in steam, not water. So the temperature now starts to go from the boiling point of water to no limit, and then you have a bad time. So it was like, do you have issues like that? Do you have where like the bottom of the pan and then we get red hot because there's like, it's like pan, steam, water, or is it going to circulate enough and you'll be fine, then it's not a big deal. And there's risks like that. There's risks like, hey, like, can you build a battery pack with the requisite power outputs to get the stats to be exciting for someone? And then there's like, those were kind of the earliest questions we would need to. And then like, hey, can we build our own temperature controlled stove, period? Like, are we capable of doing this? Because a bunch of consumer electronics people and some folks in the automotive industry and stuff like that, but like we hadn't done appliances before. So it was kind of like, can you do all those things? And so that was the first thing. It's like build a prototype that just did that. So we did that. Took us a couple months, and ended up being this kind of crazy high performance thing. We got some cool freebies out of it too, where we also prototyped the knobs being magnetic, which
how did that come to be? Like, why did you?
So I wanted to. It was interesting. I wanted to do knobs on a cooktop as part of the whole concept, but we were working through our industrial design process, and obviously you don't want to have the shaft going into the device because if you clean behind, like it's hard to clean. So it's like, can you make them magnetic and removable? And then also inspired by like Nest and how you can navigate menus like that. It's like, and also I didn't want a touchscine because the problem with touchscreens is
it'll get greasy.
It gets greasy.
Weird.
Your stove's already dirty. And so we came upon a really, really, really compelling, like all magnetic design for the knob where there's no electronics in the knob. It's just a magnetic angle sensor under the glass. And we actually deployed that in our very first prototype. So we had the magnetic knobs, we had the 10,000 watts per burner. We had I think it was like a 3-ish kilowatt hour battery. Yeah, I think it was about a 3 kilowatt hour battery that could do, I think about 15 kilowatts output, maybe more actually. And it had temperature control.
So like functionally, it's fairly similar to what you actually have today.
Yeah. So from a stats pay, but it was integrated into a server rack that's kind of like this height. So it was basically like this big. It had 4 burners. You could do it. It was about this tall. And it was basically like a server rack version of this thing. And that was the first prototype. And then we're trying it and we're like, okay. And it had a screen in the middle. So it had like some of the same UI ideas we had. This all worked. And that was maybe like April, May. So the company got founded in like July 2021, closed the seed round in mid-September, started hiring folks October, November, December, January timeframe. And then this came out, like we basically started having like this starting to get integrated March, April.
So it was really fast.
It was pretty fast as these things go. And so once we had that, we were like, okay, let's go. I think we now know kind of like roughly the bounds what we're gonna be able to do here.
But to get all the parts, like, did you have to fly to China and like go talk
to
to
people?
You
couldn't go to China. You couldn't go
because it was like COVID, right?
It was COVID. Yeah. Yes, you couldn't go to China. So like this is actually one of my. If I was like giving my past self advice, it would have been like, stop doing as much prototyping in your lab with non-production stuff. Like, do not do it. Get on a plane and do the 2-week quarantine.
And that would have like saved you a huge amount of time.
It would have saved a bunch of time because we'd have found like random vendors that, or like start DMing people on AliExpress or whatever. Like just realize that
prototyping is easy, production's hard.
You have to leave the lab and prototype with production parts because it'll save you so much time because you won't have to you don't have to do all this 0 to 1 stuff that other people have already solved for you. And so that's like the first huge. I mean, and I already knew this, but it was just like I had to relearn it because of the COVID reset and all this other stuff. So we ended up raising a Series A at that point in like the summer, but that's when we actually were like, okay, now we have to get serious, get a contract manufacturer, figure out the supply chain, all this other stuff, and then actually build a works like, looks like, built like version of the product, which is a
much different
task.
Yeah.
So that was kind of like the next, that was a thread that started kicking off. The other thing we realized was we were starting to use this prototype and we're like, the temperature control sucks. And we had kicked off a process with some in parallel, basically to develop that new type of sensor. And we basically started getting on the path of building prototypes with a more mature version, like a.
So you're almost like a year in before you even started on the sensor. Is that right?
The sensor we started like Q1 or Q2 20, I think maybe Q1. It was probably Q1 2022. Yeah. We started on it, but it started yielding results. Like we had kind of done the trade studies and all that stuff. It started yielding results on the chosen architecture like August.
Oh wow! So the
2022
lag was painful, I imagine.
And then we basically proceeded to, hey, let's build some prototypes that have that sensor in them. And we ended up building those domestically. And I'm not sure if there was a great answer to how to do it either way, but it was like that was painful as well. We built a bunch of single burner cooktops that had this, and you plug them into a battery under the table, and we tuned it till it worked okay. And that was pretty fun. And also that was actually the demo that we'd be able to show people of like what the result would be like once we actually had the product ready. So then we got to 2023, or actually end of 2022, we ended up down selecting on our vendors. We figured out who we could use as a contract manufacturer. And we kind of had a choice of like, could you go the appliance route? And then you'd run into this problem of they don't know electronics.
Yep.
Or you go the electronics manufacturer route and they may not know appliances. And we kind of found someone that different business unit of theirs did do appliances, but we didn't get access to that one. But they were an electronics one. And the other issue is you're a startup. You're not like
an established firm.
And I'm a nobody, right? Like, so like, and like we're a bunch of ex-Meta people, or we've got some ex-Meta people who'd worked with these guys before. Like, so it wasn't like super alien, but it was something where you had to build the trust and it
just takes time.
It takes time. And so I ended up, so we kicked that off in the fall. The good part is like, we actually knew like we could actually start transferring a lot of the architectural decisions we had made, kind of building those like internal prototypes to them. So it was like, okay, make sure that like you avoid magnetic components in the temperature sensor so they don't get heated by the inductor. Like we basically knew how to set a lot of the requirements now because we had done all these prototypes. So we didn't thrash them with like, hey, try this, then try that, maybe do that. Like, you know, like you can't really do that with the language barrier and stuff like that. And then we also figured out how to source a battery pack that would pass certification as well. And we ended up basically doing kind of like a half bit of like, let's do a draft architecture of the product fully. And I think I ended up doing a big chunk of that initially. It was like, this is what the major circuit boards need to be in the product. This is how we wire stuff to that. By the time we started hiring people better than me at this, like they were like, yeah, we need to completely redo this. And like, and so, and this is actually a big point, is you build a complicated product, you end up having to figure out what the integration, like kind of boundaries have to be. So you're like, okay, it needs to have these features, it needs to do this stuff. It's almost like you have like the part list, but you don't know how to like modularize it into individual testable chunks. And you also don't know like, hey, if you have multiple modules, like what's the wiring harness look like? And if you can, and it's actually fun to go look at that. It's like, if I show you an old prototype versus a new one, and you look at the wiring harness complexity, it's gone down. It's gone down a lot.
Is it like the like rocket engines for SpaceX?
Yes,
it's super complex, less complex. Third iteration, people are like, it doesn't even work, right? And then they show it working. And
What? You're like, you're missing all of the all of the sensors or whatever. And it's like, no, it's all there. And so yes, you literally have to do that kind of like Raptor 1 through 3 thing. And the danger too is like you're building a lot of these, right? So like you got to build like, so our first proto build, I think we built like 10 units or something like that. And
how much would one of those units cost to like create?
It's probably in the thousands of dollars, like tens of thousands of dollars. Like it's crazy because it's again, you're using like engineering time. Even in China, it's expensive. It's like it's not free. And like these are hand built by engineers and like, you know, it's like that. So it's, you build like 10 of them and you're like, okay, this is a good idea.
Nothing's optimized.
And then you got to write the software against it. So like you need the unit to write the software for it. So then your software team gets all busy. And so we do that. And then it took several months for us to get that thing, once we built it, to get it brought up and like working well. And we showed it off at CES in 2024 and stuff like that. But it literally took like a long time to get stuff to the 0 to 1 phase.
Yeah, like 2.5 years.
Yeah. And then you do, and that was the first prototype built at the actual factory with their supply chain.
That like actually worked.
And like, it actually worked. Yeah. It had some bugs. And that was what we call a P1, Proto 1. And P0 would be like non-form factor, or like you could call like maybe even like the lab prototypes we'd have were like, you know, P0 or something like that. And then different companies have different terms for this, but then you basically have like engineering verification belts, like EVT sort of thing like that, where you're like, this is closer to pencils down. You fixed all the major issues to your prototype, not. And so we then go into that build, which is like, so that was like August 2023. You go into EVT in like April 20, or so actually, I forgot about this. You build the unit in August 2023. The first thing we did then after that was, let's get a unit back to the US. We're going to invite the compliance agencies we're working with, or compliance firms
like
we're
to
our
facility.
office, and we will do a teardown together. And they're going to go look at the whole thing, and they're going to comment like, you can't do that, you can't do that, you can't do that, you can't do that. It's like, we were very knowledgeable to be like, let's hire a compliance expert who's done this stuff before, and let's like, as soon as we had a prototype,
you brought those people in.
You do what's called a construction review. And you basically do a teardown in front of them, and they're like
just redlining it. Like
it's a redlining
like
thing.
A doctor. Yeah.
And then you have those red lines. You have the red lines from what you found out that didn't work. You have the stuff you find out from incremental testing. You do all sorts of testing. You do like, we put it in a cabinet and make sure it doesn't get like super hot. Like you do tons of stuff. And then that folds into the next design cycle where you basically do a redesign of the whole thing.
Yeah.
And we change the shape of the battery pack. It looks the same on top, but like change the temperature sensor design pretty completely, like completely new molded parts. You have to update, and then you also go from
like all new software.
Yeah, the software architecture was totally different. It was main computers.
How many times have you rewritten like the entire software architecture for you?
It's been not super bad. Basically, we caught the big problem with the architecture before we built the first prototype.
What was the big problem?
I basically put it all in one microcontroller. And then that meant that like all the sensors went to each individual burner. So you'd have like really long sense lines going from each one. And how we have it now is like each individual heating element controls itself. And the wires go from the temperature sensor go just to a little board right next to it. And it's like, and so
way more efficient.
Like I literally have one over there, you can see it, but basically it's all self-contained. And like if you want to make a 6-burner stove, it's like you just add 2 more, and you're electrically able to do that. And so that was but you basically end up learning a bunch of things like that where you're like, okay, I actually cut the abstraction split planes in the architecture wrong. And I am learning this because I went to the factory and we tried to build it, and it doesn't fit together in this right way, or like this means this process is much more expensive and difficult, or well, if I have a failure here, then that means I have to junk this and I can't so you end up discovering all sorts of things like that you only find out by actually going through the process of
iterating.
But when I say iterating, it's like you're prototyping not just the product, but the factory. Yeah. And like that Elon quote, it's like the factory is the product is so true, because it's like, what are you actually building here? You're not building a stove, you're building a process to produce battery integrated appliances. Not just potentially stoves, and that's a big like, and you're also doing stuff that's like hasn't exactly been done before, so it's not like there's a best practices of like, hey,
there's no like how to on it.
Like if I'm
experimenting,
like your production line is a unique production line. It's a special it's a special snowflake.
The first one.
It's the first one, and so So kind of going from that proto one thing to like EVT, and a lot of people, I think I was talking to some other hardware founder, and they're like, your EVT is probably more like a P2, right? And I'm like, yeah, everyone lies about that, apparently. But basically, you end up getting most of the stuff right. And I think I was pretty proud of what we landed at the EVT bill, where it was like, it looks pretty much
good.
It looks pretty much identical to the units that are shipping to customers.
Yeah.
Electrically, architecture-wise, like almost the software is almost completely compatible. We landed every key feature in it, which was actually really like, so Proto 1, we did not have any of the inverter hardware, and we did not even have a supply chain to source that.
Can you explain what inverter hardware does?
Yeah, okay, so this is a very meandering conversation, but the inverter,
I'm enjoying it.
The inverter hardware, so you build a stove or you build so the whole idea here is like, we build, our first product is a high performance induction cooktop with a battery, but you need to charge that battery. But then there's an opportunity, which is if you're connected in such a way that you can also feed power back into the house, well, you could actually do, hypothetically, you could do grid services, you could support the home, like you reduce home power consumption during grid events,
peak periods, yeah,
outages, et cetera. So you can do really exciting stuff, and you can make money on that battery if you're also an entrepreneur like us. But you need to have an inverter that is stove sized.
Yes.
And it's not like and it doesn't intake solar panels, and your battery voltage is something weird, and like all this other stuff. So like, and it has to fit. And so we had
this little appliance.
So we had to kick off a whole program with that. And most of the inverter vendors don't want to work with like some random startup they never heard of before. And they're like, why am I making this for a stove? Like, what the hell? So we figured out how to actually solve that problem too. But that took a very long time, a lot of development work.
Yeah, and like, isn't this a whole another can of worms, like regulatory?
Yeah, so it's a compliance regulatory nightmare because. So the other thing is it's connected to the grid. So like it needs to know, the inverter has to be kind of smart. It has to like know like, oh, the frequency's starting to like drop because like literally generators upstate are starting to spin slower because there's like more demand. I need to now up my power output to help support that. Like there is an entire like super complicated set of algorithms you have to put on these things. And then you have to validate that those are all there and like compliant. And that is a adventure that you got to do. So it's and this is basically, there's like, not only is it a hardware thing, but it's a software thing. And the software is where all the IP and complexity is. And if you're a startup, like you're not going to solo that.
I got to imagine. So do you have just some like, I don't know, love for doing maybe what you believe is right, but that's just like an extremely painful and difficult path? Because it seems like at every kind of turn, you're doing the hard thing that may make sense if you can actually pull it off, but it's not easy.
Yeah, I would say this is I would say like there's probably different ways to do this business that may have gotten wins faster. The problem is you still have to make the thing compliant to be able to actually ship it at scale and put it in people's houses. So it's like, we would still have to have the battery, the stove, all this other stuff certified and like go through all this process. So it's like, okay, if I had that done now, then I need to sell these. Why would someone buy my thing versus someone else's? Well, it needs to be higher performance. Yeah. And if it's higher performance, I need to have this temperature sensor probably, because it's not just about power. It's about like delivering that power in the best possible way. There's probably things we could have made easier about executing the product, industrial design, various other things like that. But like, and then you're like, well, also, what's the big picture here? Why is this the company? Like, I don't want to just be a stove company. I want to be like something bigger than that. And it's like, okay, then you need to do this inverter thing too.
Like a full appliance company that's like multiple things.
So the vision here is actually taking a step back, is like, this product is the vision in one product, like landed, which is you build a better product than everyone else in this category. It just mogs people, to use a word from your generation.
Destroys all current competitors.
Destroys all, yeah, it just is incomparable. People thus want it in their house. They figure out how to get it in their house somehow. Even if like you're renting, you put it in a cart, sitting on a table, whatever, you get it in your house. We've now installed a battery in your house, and we're now building a new distributed power grid out of all of these battery assets that are at the very edge of the grid. And we can, because what that means is if every device with a power cord has an embedded battery inside it, suddenly, and maybe we control the software of that, we control all the consumption on the grid. We also control a good chunk of the storage as well. So you end up being like the primary counterparty, and you're very flexible to all the generation assets.
Yeah, and it just makes the like entire grid way more flexible. Because I think you talked about in the like Ashley Vance thing that there's something like 400,000 Powerwalls right now from Tesla.
That is an out of date number. Apparently, they're doing really well right now.
They're growing like crazy.
They are growing like crazy. But basically, the point is, I think the point is in order of magnitude about that. But then you think of like how many appliance installations happen in the United States every year? It's like 55 million.
Wait, really?
In the United States.
How many houses are there?
140 something million.
So it's like roughly 1 in 3 years you're getting a new appliance.
Yeah, because you think of it, you have like 3 or 4 appliances and they replace them every 10 years.
Okay.
Probably a better way to put it.
Okay.
But that means that there's a Best Buy truck on your block probably once a week or something like that. Maybe not your block, but like in your area once a week delivering an appliance, which means we've gotten really efficient at installing them cheaply. It's like installing a 240 volt appliance is like a $50 task that we've kind of worked around some of the electrician requirements, various other things. Like we've gotten efficient at that. Whereas like a Powerwall installation, unless you're in a jurisdiction that allows their meter socket adapter thing, which makes the installation a lot easier, just $6,000 for the install. And
so it's like 2 orders of magnitude.
Yeah. So it's like the cheapest way to get battery storage on the grid, if you want to get home battery storage, could be just if people are buying nice appliances, sell them nice appliances that are the same price, and they just happen to have the batteries in them. And you've automatically...
Is there a future where you are making your pizza oven? Like,
yes.
Are you going to make that?
Yeah. So this is actually, so like walking through like the development pipeline and stuff like that, it's like basically we had to do a bunch of different revisions to this one product. And what we were also doing at the time and kind of going from like proto to EVT to DVT to PVT and ramp, which is like we're shipping imminently right now. You're also maturing all the key modules inside the product. So like the power electronics, that inverter I mentioned, the battery pack, you're getting all of those, the sensor, the software. You have to certify the software for the control system. So everything from the knob turn all the way to the temperature sensor and the induction, that's a certified set of software that like UL actually looked at. And we got a UL 6730 cert, which is like for functional safety as part of that. But all that stuff is now durable IP. And we have a supply chain that can produce it in high volumes with the consumer, like a consumer electronics supply chain that can produce in high volumes. Our battery vendor is a very well-known company. So now we've got all these key modules. So how do we expand? Like what's the big thing with the appliance industry is I don't want to make 100 different devices on my website. Like you can because people are like, okay, you make this one cooktop in one size. Like, but mine is this. I have a 48-inch range in my kitchen with like 2 ovens and like 8 burners and all this other stuff. Like, how could I swap in your thing? And it's like, the answer is you're not. And I don't see, and we're a technology company, not a expert at making a million SKUs and a bunch of appliances and distributing these.
You want to make a few products really well.
And we want to make a few products really well, but then additionally, figure out how to scale that technology as broadly as possible in the market. So we've started announcing big partnerships with major appliance OEMs. And what that lets us do is say, hey, all of that IP that we've developed and those power electronics we developed, and in some sense, this is the tech stack of the future. It just happens to be stove edition, and at least for now, but you can think of how this applies to ovens, water heaters, fridges, like laundry, stuff like that. You offer the electrification tech stack, the software, the control systems, even like customized UI, things like that, and the battery and the inverter to these large companies. Maybe you help them integrate them into their existing products or help them define new products. And now you've got reach through every showroom in the United States.
Oh, so you're basically just like hot swapping whatever they have in the current showroom with like way better technology.
It's now like
it's already
we're working on the branding, but it's like powered by impulse sort of thing where it's kind of like Intel inside.
Yep.
And so their next gen products, instead of being baselined on like the equivalent of like Bosch and Continental supplying Ford, it's like there's actually a German company that supplies most stoves as well. So every induction stove, if you see that 0 through 9, same stove. Or even the knobs have like 9 or 18 defined positions, same company. So instead of being the equivalent of Bosch and Continental supplying the big 3 or whatever, it is much more like Tesla supplying Daimler and Toyota with the RAV4 electric and these other things. But to our
giving them like initial orders and stuff.
But the advantage here is this gets us like, it puts batteries in everyone's house, and it puts batteries in people's houses that have no connect, like that are like in mid purchase stream of like thinking about getting an appliance. So they go to a showroom, they go buy one, and ours is the one that's working on the showroom because it's got a battery in it. So they don't have to plug it in. It doesn't need a gas line, like all this other stuff. So they go try it, and it's the best performing product in that showroom. So obviously they're gonna go get it. And they don't have to go wring their hair out over like this new brand, or like, oh, that's the Twitter stove or what. Like, you don't have to worry about that. It's like you go to some brand you already know and like, maybe it's one you already have in your kitchen, and you get the new thing, and then suddenly all of the benefits of impulse technology are deployed.
Yeah.
And so that's how we see the scaling, where it's like, I think you can build kind of the Roadster or, plus, because I think we've designed this first product for real scale, but you can then use that to get the platform out. And then the platform ends up being this very long arm that reaches
just everywhere.
Everyone. Yeah. And also it means that we don't have to hold like the margins in like the low end of the appliance industry are utterly terrible. But like, I want to get this technology out into like,
so you can turn like a bad business into
home.
an awesome business.
You can turn a bad business into an awesome business because you're basically like, I don't have to be in the business of distributing low margin stuff. I can distribute high margin power electronics, and I can make all the money on the battery storage.
So you get like a subscription on the back end as well as,
Yes. And so, and we're a little quiet about how that exactly works, at least, publicly. But basically the point is like, if you have a battery that's on the grid, it is worth something. And if you have software control over it and permission from the homeowner to do so, and I believe we've found a way that kind of squares that circle in a nice way, you can do something pretty awesome. And what's also great about it is the appliance industry is stuck in this spot where like they really need to charge people for repair and servicing and all this other stuff. And it's like, it's kind of a cost center, or it's like, maybe they can make money on it, but it's not something that like, they're not going to go out of their way to like help fix your stove and keep it operating. But if you flip the script where it's like, oh, it's actually in the interest of us and the brands to make sure that every appliance is just rock solid and works forever, because that means the battery is attached to the grid.
Yep.
That's a very different value proposition for the consumer, because they know like, oh yeah, like if my stove goes down, like they'll give me a new one.
Yeah, that's a crazy business model. Okay. So I know that you're like partnering, or I guess I don't know if you're partnering with a bunch of like creators, but you're definitely like, this is such an awesome product because there's so many people that like people love to watch that are making amazing food, So how does that work?
So
we're building relationships with those guys.
Yeah. So this has been something that's been very interesting, where it's like, we build this product that has a bunch of safety requirements, and it's also just like, it's kind of, I think we're a bunch of perfectionists over here. So it's been like, I've been fighting the urge to be like, don't let it out yet, just yet, but like, we're ready. And so that's the exciting part now.
How long have you been fighting that urge?
I think we could have gotten away with it 6 months ago, and people would have been like, this is a crazy awesome stove. Because like, people come to the office and like try it, and they're like, yeah.
Makes obvious sense.
Yeah. Can I get one? Like, can I just grab that one over there? Like, it's like that sort of thing. So, but the big part is like, we're ready. We're ramping production. There's a bunch of boxes in the front that are going to go to VIPs and stuff like that. So like, it's finally happening. And I do want to shout out like the Matic Robots guys, because like they've been grinding for years on that thing. And then now people are getting, and that Wired article came out, but then like every random person is like, I bought this thing. This is not a sponsored post. I'm not a VC that invested in this whatsoever.
It's just really good.
It's just really good. You should get one. It's $1,000, but you should get one. And I'm just seeing that, and I'm like, cool. That's the goal. Let's make sure and I think we're going to hit that. So it's pretty, which is pretty awesome.
Yeah. What was it like? So I know that you said that you were able to like raise, seed and A without like too much,
that was in the before times, but yeah.
Right. What was it like? So I think like Lockie Room was the first check.
He was one of the co-leads for the seed round. Yeah.
Right. And he was also the first guy to get a stove.
He was the first guy to get a stove.
What was it like delivering that first stove?
Well, so I didn't deliver. It was some other guys on our team did actually. Well, they couldn't get into his house first, which is a funny story because he wasn't home.
So they're just outside his house with a stove.
Yeah. It's funny though. I think I need to swap his out because his fan he has the build before the production unit, so his fans are louder than they should be. So if you've actually checked out Lockheed's stove, the one I replace will be better. But it was actually what was funny with that one was that was proof that it was ready, because it was just like he would just text us the most anodyne things being like, this doesn't exactly work like I expect. Can you fix that? Things like that. And it's like, totally fine, reasonable stuff. And I'm like, okay, if we let this thing out the door and it's working and it's OTA updating and all of that stuff is working, let's just make sure that we can keep doing that and getting the stuff out. And
does that cause any problems, like regulatory wise? Like,
no,
are they?
It's a sample, not for sale.
Okay,
you put a sample, not for sale sticker on, it's fine. But there's ways to handle low volume prototype stuff.
Yeah.
But like as soon as you've got consumer, like a consumer purchases it, you got to have FCC Part 15, Part 18. We had to do some crazy stuff to actually make that pass at the super high power output for the inductions. Like there's some crazy stuff we had to do, which I can't talk about until the patents are fully filed, but you get the on some of that stuff. But it was crazy. Actually, it'll be filed by the time this video airs. But basically, that was hard. You also to install it in people's homes, you want the UL cert as well. It's not like there's a police siren that goes off if your product is not compliant. But my understanding is like there's no like retailers, showrooms, all this other stuff, like they won't sell products that are not listed.
Yeah.
And so getting all that stuff through, it doesn't gate giving it out to VIPs and influencers or anything like that. No one, unless you're really like deep wonky in the space, you don't necessarily know this sort of stuff, but it's not required for handing out prototypes to cool people, is required to ship to consumers.
Yeah. Yeah. Do you okay, so you're just starting the ramp up on actually producing the stoves, right?
And delivering.
And delivering. Are you experiencing like production hell, just like Elon would describe?
Yeah. So the production, I mean, the thing is we've built several hundred of these already.
Mm-hmm. So you already went through production hell to some extent.
Well, it's funny because
pre-production hell.
Pre-production hell. Because you find out, like, so this is where you find out like, okay, the product goes together poorly and you have to redesign it, kind of thing. It's like a simple thing. Or like there's actual problems like, oh, you're failing FCC Part 15 because when you turn the induction on, like you get like spurious emissions in this specific frequency that exceed something like that. And like, that means you have to change the design, right? So like you have to then go and feedback. Or you have process issues, like we've got a bunch of like silicone seals on our product for the industrial design, like the robot that dispenses the glue. Well, they just randomly decided to change the glue today. Like, and like, it's that sort of
stuff that you like can't necessarily plan for.
Or it's like you have to, in some sense, you have to understand all the processes that go into the system and make sure that like those are conscientiously managed, or like they're consciously managed. And so like, because if there's you don't know what you don't know basically until you go and do it. So you end up building a bunch of these. And so we had kind of like a wave of EVT units. Some of those went out to like demos, internal people's houses, stuff like that. Those got superseded with the DVT units, which are pretty much mostly exactly what we want. And then like the production or PVT production units, basically like apart from like the first batch not having our logo on the box, like and like the manual in there, like are identical to the production intent design basically.
Yeah. What's it been like? So you went and worked with Facebook in like 2014, 2015, I believe. And then
2016. And then I went back to
back to Google and back and forth. Was that like super helpful as far as, having these like moments where you're in China for 9+ or
not 9 months in a row,
3 months or whatever.
It was 2 weeks at a time, off and on, all over and over and over again.
Right. And you're like building those relationships. What was that like building those relationships back then? And how's that translated to today?
Yeah. So, I mean, the big thing is, I think there's kind of this like, I think I've said this in other interviews, but basically like, and this is maybe for like kind of the earlier career engineers in the audience, maybe, or people just entering hardware. It's like the misperception of like Tony Stark in a cave with a box of scraps soloing an Iron Man suit. Like you're not going to be able to solo a consumer electronics product. And the worst decision you could ever make is doing that.
Or trying to. Yeah.
What you want to do is you want to build a Lego kit with the best Lego bricks you can have. And ideally you have an 80% complete Lego kit that you can like, maybe you have to build it.
Assemble.
And then maybe you've got some science project to figure out some special colors of bricks or whatever.
Yeah.
But you need to basically understand where those bricks come from, how that works. Like you have to like understand like
supply chain,
how stuff is made, like, you know, all this other stuff. And so I spent a ton of time in China with this sort of stuff, but the Oculus experience was honestly fantastic because, so to give folks color on this, and this is over 10 years ago at this point. So Oculus gets bought by Facebook. At that point they had shipped Dev Kit 1, which was he was like an LCD, it was basically an LCD screen from like a tablet with magnifying glass lenses, I think, basically, or the lens design was cloned from a magnifying glass, if I remember correctly. They had their own supply chain to make the lenses and stuff like that. And it was built by the manufacturer that built, I think, Rock Band or Guitar Hero's controllers.
Really?
Yes. And this was like southern China in Dongguan. I visited this place once, and it was like kind of a little seedy, not exactly like, does not look like these like the Xiaomi EV factory,
where it's like super clean,
automated, looks fancier than Tesla's thing. Like, no,
this is a bunch of guys.
No, this is like, oh cool, a warehouse in the jungle, like, you know, sort of thing like that. Old China.
Was it sketchy?
I don't want to get you a strike on YouTube, but basically, so in China in 2014, there were multiple waves of kind of like crackdowns by the Chinese government against undesirable behaviors. And 2014, I remember checking my hotel in Dongguan, and the guy, and this was, I'd been to China before because I'd been to China in 2013 with Google, and I got to go tour a bunch of camera module vendors. I worked on the camera for Google Glass. And so I went to Shanghai and all that other stuff. I had not been to Dongguan before. So Dongguan is like one of the biggest factory towns in the world. Like it's like Shenzhen. It's just near Shenzhen. And so I go check into my hotel. It's like a international brand, nothing super crazy. But the guy who brings my bags up to the room is like, 5th floor is massage, not sex massage. Sex massage outside. Sex massage is very famous in Dongguan. And I'm like,
thanks for letting me know.
I'm like, thanks for letting me know, man. I'm just 23, man. Like, what's going on?
Just trying to manufacture some stuff.
So then shortly thereafter, the government raided all of the massage parlors.
Oh my God. Yeah.
And so they cleaned that up. They cleaned up a couple other things too. But you know, that's when I go on some China podcasts, I can tell those stories. But the experience though was after that, we actually started with, so that, I think it was that trip, we started touring kind of manufacturers for the CV1 units, like the first consumer version 1 of the Oculus Rift. And that was like, obviously they got bought by Facebook. They had much more resources now. They didn't have to go deal with like, and they didn't have to, they again, the manufacturers that would work with them now were everyone, like including like, you know, up to like Foxconn or whatever. We ended up touring like they ended up touring a bunch of different people, a bunch of different places. The selected place ended up being more in the north of China. But I then had to go all the time.
Go all over those.
I had to go all the time because what was happening was I actually ended up, so I joined and I was like an electrical engineer, or like I did camera module and some other stuff like that. But the headset, like the team had already kind of had enough electrical engineers to like design all the electronics in the headset. Like there wasn't like, you know, some random new guy who's like a big tech person parachuting into this startup, even though, you know, it's becoming big tech. I'm not going to go take over other people's stuff. And I was like, what gaps are there in this company? And I ended up building out their factory test system. So like how to test all of, like, if you put a lens on a screen, how do you make sure there's no dust inside? And so I built like computer vision inspection systems for that. And what this inadvertently signed me up for was to basically stay in China continuously, getting all of that stuff working.
Yeah, figuring it out.
And it was like it's kind of like an industrial automation plus software plus computer vision plus unintentional accidental cybersecurity incidents plus plus a bunch of different stuff. But the other piece of it was a lot of learning on how to use these manufacturers to like actually prototype stuff and because when you do production development or when you do development with a production vendor, you're playing for keeps.
Yep.
You're able to basically say, hey, if you make that, if you add that part there, now, well, the production design has that. Like in this case, like the factory equipment will have it. And that was kind of the beginning of this lesson. And I kept revisiting this lesson over the course of multiple projects at multiple companies where it was like
trips to China.
And it was basically like, look, Silicon Valley likes to think they're the smartest guys in the room. No, there's smart people everywhere, but like if you are close to the factory and you have the ability to, and this is again why the Elon universe is like very effective, is they're close to the factory. You're able to actually like play for keeps where like I make a prototyping decision. And then instead of me buying some part from some lab equipment vendor, I'm actually using the real part that would go into the real thing. And then when I write the complicated software against that for like, hey,
it'll work.
I know, and then you'll know it'll work for the actual version. Yeah. So, and then the other piece is like this kind of respect of like, okay, you're working with this manufacturing partner. There's kind of they're just as good as you guys are. They're just different.
Or maybe even better.
And you should be optimistic about their skills versus pessimistic on their capabilities. Now that's not always the case. And that's maybe one of my faults of being like, just assume they're going to probably be able to pull it off. But what that means is you get a ton of leverage because, and this actually is taken over to what's going on in Impulse. Like we're 25 people. We get to use like 100 plus people across our supply chain to make this product happen. And that's how it can be significantly more complicated, both on like the hardware side and on the like regulatory side than like any other consumer product that I've worked on before.
Yeah.
Like this is more, I would say a VR headset's different challenge is like you need an app store, you need a lot more software on top of the device in terms of like kind of building out the universe of what you can do with it. But from a like, this has probably been one of the more complicated devices just because of how unprecedented this is from like both us doing it and for like our supply chain partners doing it.
Yeah, I'd imagine that this is like the first time that they've ever put a massive battery inside of a stove.
Yes.
So,
yeah. Or even then, like first time our manufacturer has gone and like worked with like inverter vendors and like sourced induction coils and like all this other stuff. So it's not like they've got a 80% similar product that we then went and mutated basically, which my advice to other hardware founders is do that.
Yeah.
But once you've built all these modules that are now special, I'm like very proud of like the product we've now built, which is like all the stuff on that table over there. All of those modules we can sell into everyone else's appliance channels.
Yeah. You just take advantage of everyone's distribution.
And you take advantage of everyone's distribution. And then you go from selling, you go from being a stove salesperson to we build the power electronics platform for the for the electrified era. Basically.
Ironically, Stove Guy is actually going to be like the Lego kit guy, and he just like he sells the Lego kit.
Yeah, it's you sell the Lego kit, and you sell the Lego kit with the SaaS software that makes the battery make money. That's as simple as very simple, right? You just have to make sure that that Lego kit is UL listed and like all this other nonsense, and and you've talked to all the utilities and stuff like that. So.
Yeah, that's awesome. What was so how did you end up building like the initial, I guess, like relationships with the regulatory people for this? Because you started very early bringing them in. So how'd you do that?
Yeah, so I actually think that's I don't want to spoil the alpha, but it turns out that basically the trick there is you cannot under any circumstances, this is the first thing I'll say is you'd be like, we're done. Let's get this thing certified. Now, if you're like if you're like, again, if you're 80% the same as something else and like there's nothing special about it, like you can often do that and like you use the same suppliers. The problem is, as a startup, you don't usually have your own test lab. And so these big appliance companies actually often have their own lab where like UL already signed off on the lab. And then the UL like inspector will go visit when they run the test and confirm that everything works. But you're doing the test at your own facility. And so it's like a lot easier. In our case, it's like, no, we're like going to some compliance agency's lab and doing
Are you like bringing
the unit? Yeah. Wow. Well, so the first one is you get the engineers to go look at it, and like that's relatively straightforward. But basically what we had to do is we're like, hey guys, we know this is crazy. We want to go by your rules. Let's like run the process in a reasonable way, and we'll start way ahead of time. And so we have
how many like cycles did you go through with regulators, to say like, okay, you have some initial version, you bring that to them, get feedback.
So I mean, and this is actually a key point is they're not, so the only regulator that you have intersection with formally is FCC. But FCC doesn't do the approval. You go to like a approved lab and then you run the FCC certification. But the certification bodies are what they're called nationally recognized test labs. So like I think it's like OSHA and the various building codes cite like which ones they allow. So like in the San Francisco building code, they're like, if you install a stove, it's got to be UL 858 or something like that, sort of listed.
Something
specific. They'll say something specific. So you go to those nationally recognized test labs. Those are private companies. They just happen to be like.
Oh, really?
Yeah, they're private companies.
Oh, okay. So it's like a privatized DMV kind of thing.
It's not a DMV. It's probably less like a DMV and more like the government has essentially said, we need to define standards. Those standards are maintained by
some organization.
Yeah, some organization. Yeah.
Okay. Interesting. Yeah. What has it been like? I know that you said that it's been slightly different since like 2021-ish, right? But what has it been like fundraising for a hard tech company in San Francisco?
So, yeah, I mean, I think San Francisco has also gone up and down through a bunch of, euphoria to depression to a euphoria. But, that's the name of the beast. This is it's a gold rush town.
Yeah.
It's a gold rush town. We've replaced gold with, I don't know, five things since gold. So 5 or 10 things since gold. It's like every 20 years we have a boom and bust cycle, or every 10 to 15 years almost at this point. So
but are the people that are like investing money, are they the types of people who are like, I want an awesome stove? And so it kind of just like naturally makes sense?
No.
Okay. Or do they not even cook? They just DoorDash.
So I mean, I think the big thing is consumer hardware is like, I think there's some fantastic consumer hardware companies, like shout out Framework, shout out like, there's a shout out Nothing, like, fantastic consumer hardware companies. And some of these guys are doing great, but it's weird where there's like, you have these fantastic companies, but there's not, and they have real revenue. The margins are not bad. Like everything about them is good, but it's like, because of the kind of like boom and bust of the Kickstarter hardware era, there's,
this like stigma,
or not stigma, but it's just like, I think there's just not enough people tried again.
Okay.
I just think there's not enough people who, and I think Narav Framework said this was like, he was like, I wish I did YC for Framework for one reason, because it would have been such a win that YC would have been like, cool,
we should fund more.
We should fund more of these. Yeah.
Interesting.
Because it would have been such a win and then what that would have meant is, even though he would have given up the 7% or whatever, it's like the ecosystem would have been then ready at the later stage, so that like the competitive round, like it's like it would actually have been better for everyone basically in those sort of situations if like the winners went through some like accelerators like YC. Now, so 2021, like basically there's the zero interest rate situation where it's like, yeah, you're gonna be able to get and like arbitrary debt financing to build a factory. Like essentially like 0% interest rates did that. I do think there's some interesting thing though there, which is it also caused like people to just invest in things that didn't do anything. Like, okay, well, why would I bother to build a hard tech company when I can just do crypto? Like because you can get liquidity super quickly. If you're in a zero interest rate environment, you're
not incentivized to do the factory instead of
you have to actually build a factory versus like I could just launch a ape. And so
make the same amount of money or more.
and you make the same amount of money more. And it's like, and I'd be done with the ape thing. Like, you know, I'd be done and dusted.
You
like,
almost seem like an idiot for not doing the ape.
yeah, I'm not, no, all my apes gone, man. I don't know.
Yeah.
So
I never touched the apes.
I never touched the apes either. My friend has a CryptoPunk, I think. So, but actually, a bunch of my friends have a bunch of all this stuff. But the point though is now that we're in a higher rate, scarcer money sort of environment, actually, weirdly enough, it does feel like a better time to actually do hard tech because it's the only stuff that makes sense now.
Yeah.
Because like you can't do a ZERP thing. Well, the business models that made sense during ZERP, which is like, cool, I'll finance loans for burrito taxis and burritos, like, you know, like pay for your Chipotle with Klarna kind of thing, like that. Like basically you have like stuff like that. You had like,
that's actually just happening. That's just
that's
starting.
just happening right
so I don't know if that's necessarily a great example, but
yeah.
Higher interest rates equals burrito finance. Well, actually, people are defaulting on the burrito financings, which like the CDOs of burritos are going to zero. So,
but the point though is, I think now, so I think there's actually a specific story with us that I should actually tell you about, which is, so basically like Seed and A was kind of under the premise of like, how do you distribute lots of appliances? And it was kind of like, or not kind of, it was actually this thinking of, well, you build like the Tesla of stoves, and then you figure out how to get a bunch of multifamily developers to buy a bunch of these. Because who's the biggest buyer of
new developers?
Right. Like who are the bulk buyers of these things? Or like cities that are forcibly decarbonizing their buildings, like New York or something like that. So like, I think like that's probably the market. And what was interesting was, okay, we're working on the product, we're figuring out how to actually make this thing, but then at the same time we're trying to figure out how to sell it. And very clearly you can sell this thing on Twitter by like showing cool videos, but that's not going to get people in the place and time where they may be literally in market for a stove. Like they have to be like,
you talked about this, like this is not an impulse purchase.
It's not an impulse purchase.
Are thoughtful about.
You have to be thoughtful about, and also like
it's more like a car.
No, not even like
is it actually not?
It's less like a car than you think. What I mean, it's more like a car.
Because you can actually impulse purchase a car. I've seen people do that.
You can impulse purchase a car because you can always get a second car.
Right.
You can always trade in your car. Whereas like a lot of this stuff has more architectural implications. And it's like also we make one form factor, we don't make 10 yet. Like there's those sort of problems as well. Even though like cooktops, like they sell millions of those a year, like no problem. So like the big enough market, not a big deal. But what subsection of the people that have heard about you like in a D2C context online, then you go kind of like narrow down the funnel to like have the exact slot your thing would be in, or in mid remodel. Like you kind of like go down that funnel. It's like you can do it. It's just not something that you would necessarily want to bet your business on at like, and you could like, I'm very convinced you can sell tens of thousands of units this way, no problem. But you're like getting to hundreds of thousands will require you to have many SKUs, and then you have the same product dynamics as a appliance company where you're probably not going to actually be. You need to raise from different types of
like capital providers.
It's a different business basically, because now you're kind of in the distribution pack. You're building.
Do you even think that this was like the right first? Like, did you make, not even necessarily on purpose, like the right product first? Because if you had done something where you can just like plug it into the wall and it's just that single burner on this countertop or whatever, and it's just like extremely good at being a little burner, like that might have been way easier.
Oh yeah, that would have been way easier. So I've actually got, it's essentially a good friend of mine who is an amazing consumer founder, shout out to you know who you are. He pulled me aside and he was like, do you want to just pivot and do that? I'll like
literally what I was just describing.
He's quite successful. He was like, do you want to just pivot and do that? And like, and I was like, I actually went through the whole thing. So this is where D2C gets really tricky. Imagine you ship this thing that's perfect, and there's no engineering difficulties of like fitting a smaller battery in with the right power levels and stuff like that.
You can ship like an Apple level product, that just looks beautiful.
But imagine I ship that. And then imagine someone else. Let's imagine someone with like, let's imagine some pan brand that's got like 5 million followers.
Hexclad.
Yeah, let's use Hexclad as a great example. Hexclad says, we're gonna have a Hexclad hot plate with temperature control. And it looks kind of similar. It doesn't have the battery. but do the consumer understand any of those? Like, are they drilling down into those features, or is the marketing for Hexclad just so much like basically? And even if I have a product that's better, I'm now 1v1ing them on Meta display ads.
Yeah.
It becomes really tricky in that space. And I talked to some folks that had done this before, and it's again, you end up in a situation where you end up having to get specialized in the distribution.
Is it like a local maxima or kind of thing? Or
that's a local maxima. So like, I'm pretty sure we could sell an amazing product there. I want to actually make that product. I do not view it as that is not the product that makes the company
worth billions of dollars.
Worth billions of dollars. Yeah. It would basically mean that, oh, cool, this is a cool e-commerce brand that has not iterated on this tech, and it has like a zombie version of what we put in this product, and it's not the same thing. And then we would have to get really good at e-com distribution in a very competitive advertising market, and the cost structure has to work, which is again really challenging. It's like, can you actually deliver that in a like sub $1,000 price point?
Does this make it easier to sell the Roadster? Like you're selling the high ticket item and you get it down over time, that kind of thing.
Well, so what was interesting with this is this was actually like, so my very solid consumer founder friend said like, this would be the concept. And what he was citing was literally the distribution problem, where he was like, he talked to his friends being like, hey, are you in the market for a new stove? When are you going to swap your stove out? Like all this other stuff. And it's like, this is a relatively illiquid market.
Yeah.
Even though it is a big market with lots of sales, but it's something that like Silicon Valley does not understand how to sell into. And
I think people, even if they have like a shitty stove, don't think about buying a new stove. Like it's just a stove.
Yeah. But the point is basically this is, So, and I actually think that weirdly enough, we have a product that's like special enough that we can exist in our own space where it's like, I want the impulse thing, so I'll make it work.
Yeah.
And we've got customers that have told us like, hey, we're cutting a slot right now. Send us the stove the next week, whatever. So like totally can work. You have to be extraordinary. And that was like, okay, that made sure that we had to bet on the product being extraordinary. But then the second piece was, okay, the multifamily angle. There's a couple companies that were doing like smart door locks and stuff like that, selling into multifamily. And in the zero interest rate environment, all these multifamily operators like were flush with cash. They wanted to invest in improvements because they could finance them at like
no cost.
And then they could basically increase their rent because they've got a cool stove or whatever. So we went actually and called some people up and figured like, what's the price point that you would be willing to swap
the stove out? Yeah.
And it was like sub 3,000, maybe like 2,000 or something like that. Even if it was like full range with a battery, like it's like
you just like couldn't make it work kind of thing.
Well, it was also just like, that's not a profitable market.
No.
Meanwhile, like a huge chunk of the appliance market is high-end remodels. Like, so like probably most of, like, I'm not sure if it's most of it, but it's like a lot of the value is, but how do you access that? And, one way is you build a premium brand and make it work. But the other one is, well, you have to find these existing brands that are already distributing and get your tech inside them. And that required us to build the highest performance stove that exists. Like we had to build this specific product because that was the technical marketing
to actually do the next
to actually make this work.
Yeah.
And what was funny was I then talked to that friend who was like, you should go build the single burner thing. And I was like,
when did you have that conversation?
It was like September, or it was like August.
So it was like recently?
It was August or September last year. Yeah. And it's like, I had just, And so, and I was trying to figure out like, hey, how do I actually go and secure enough financing to actually fund shipping the products and stuff like that? And he was like, don't do this. Very good idea. You should pivot. And he told me a previous story of like, he had a burn the ships moment kind of where it's like, no way, like we're not going back. We're going to delete this repo and like literally focus on this new product and it's going to work. And I then went off and I was like, okay, there's a big gap in product is technically fantastic. I think everyone thinks we're going to stick the landing on this thing. And then there's like, what's the distribution angle? How does this turn into a unicorn? How, like, why are the comps like appliance companies that are worth like 1x revenue and stuff like that? How do you actually escape that
Well, what's funny is I think that Tesla is actually a really good example of
No, they're a
this
really good example.
because all the automakers, like if you just add up all their market caps, like they don't even touch Tesla. It's a completely different business.
It's a completely different business.
Yeah.
And I think, but it's really annoying to be saying like, oh yeah, we're making the Tesla stoves. But it's like, I had to study like not Tesla. The Tesla secret master plan is a misdirection. The Tesla secret master plan was build a fast car with a really good power electronics and battery platform, and then license that really good power electronics and battery platform to car firms with lots of money that can get you lots of distribution. And then while that's happening, slowly build your direct to consumer profile until you can sell directly. And now, but what were they underwritten for their IPO? It was the platform play.
Just the car.
It was the platform play.
Yeah. I think they were like just turning on the Model S line, like when they went public, right?
It was, I think it was barely. It was
Yeah.
it was like
To finance it kind of thing.
Yeah. But basically the understanding that was like a key thing. So I actually went back. I was like, let me take like 5 steps back. And I was kind of like, what companies exist in the world that do not exist in America that should? And I kept coming back to BYD, among others. And
for those that don't know,
so BYD is the largest electric vehicle manufacturer in the world.
Yeah.
They build everything from
I think
their
it's like
own
4 million, 5 million cars a year right now.
It's something crazy. They also build gas cars. They build
and hybrids.
They build iMacs.
And then they have just like a
batteries.
shit ton of other SKUs that you've never even heard of.
They have stuff. They made half the COVID masks in the world because they made those on the battery cell lines because like laying films on top of each other and like cutting them.
I think that Charlie Munger said that basically like the guy, I don't know his name, that like started BYD is just like an absolute mad genius, just like insanely good.
And so the other thing about them is, and I've said this in other spots, is they have the best Lego set in the world because the way they operate is they have a bunch of different ways they make money. They also sell monorails, among other things. You can buy a monorail from them.
What?
Like if you want a transit system for your city, you can go to BYD and they'll make it for you. So it's kind of like if you smash like Siemens, like literally, or like Schneider or something like that,
Just
with Tesla, with Foxconn.
Yeah.
They also make like some huge chunk of they make everything.
And aren't they just like opening, I don't know, I think the biggest factory in the world by like a massive amount? An entire city size factory.
Yeah. Looks like some of these like old Soviet munitions factories in terms of like the size of the footprint and stuff like that, maybe bigger. And so this is an incredible company, but the biggest thing is like they build stuff with their own IP. So like if you go to them and say, hey, like Nuro is a good example. Like Nuro is the self-driving delivery vehicle. Yep. They basically said like, hey, build us a car, and
they'll do it.
And like, you know, with very high level of fidelity, they have some of the best engineers in the world. They'll assign them to that. It's like if I could rent Tesla to build me a stove. It's that level of fidelity. It's pretty crazy. And then if you go look inside that thing, it's like BYD powertrain, all this other stuff, and they're getting margin from all of that stuff inside.
Yeah.
So in a sense, they're both, you know, like you could think of them as like they're the like future electrification stack company. They also have first party products, but they also will build third party products on top of their stack, basically. And the US just doesn't have anything like that. Like the closest thing would be like if like a future administration wanted to like bother Elon and be like, hey, we're going to Defense Production Act Tesla, and now Tesla has to build stuff for other people or something like that. Like that would be like the closest. And then Tesla would have to, and by the way, and then to do that, we'll fund them to go buy up a bunch of Midwest factories that they'll manage or whatever. And that's the equivalent, that would be the closest thing I could think of to this, but it's a stretch.
Yeah, I would also kind of imagine it's a little bit like Tesla if like SpaceX and, you know, Starlink and Boring Co. and all these other things were just smashed into Tesla. You know, it's just like one big overarching company.
But then Stove Guy could go and order a stove from
right. Oh yeah. And then they also do like custom stuff just for you.
And they would use custom stuff for just for me. And it would use and my stove would use the battery modules from the Powerwall line plus like the power electronics PCBs we made on the Starlink SMT line. Like it's if you think about it that way, it's like that's the sort of level of like
Elon's letting you use his hardware in your own product and kind of thing.
Well, you essentially get access to the machine that makes the machine, basically. And so this company is absolutely amazing. But what I've realized was there's nothing like this in the United States. And there's also this huge opportunity for, like, basically, if you look at kind of the electrification stack today, there's like companies that are vertically integrated brands.
Mhm.
And then there are companies that, and they actually have control over the stuff. Like Tesla makes their own motor controllers and motors and all
Just the
sorts of
entire,
stuff. But there really aren't. The U.S. doesn't have like any sort of core capabilities around like, hey, if I want to buy an induction drive board for my American stove brand,
it just doesn't exist.
It just doesn't exist because no one has gone through the certification process. Like one German company will do it. And then like there's an Italian and a Spanish company, but they're not UL certified. So
are you trying to think of your company similar, like Impulse, similar to BYD? Not exactly, but
not exactly. But I do think that there is literally this play where there are brands with existing distribution, but none of the electrification, or none of that do not offer the kind of the technology stack of the future.
Like you're basically just coming into a bunch of different existing distribution systems and saying, I have an amazing product and you guys can.
I have an amazing power electronics platform.
Right.
And I can intersect it right at like if you think of like the appliance market, it's like consumers, and then you've got thousands of showrooms, and then you've got hundreds of SKUs per tens of brands. Like it just gets to this crazy thing. But then you're like, but they all use the same induction drive supplier.
So you look under the hood and it's just all the same product. Like,
but then it's
same
like,
stuff.
so it's like, okay, I will compete there.
Yeah.
And if I compete there, I then pull a battery and an inverter into the product, which then means I can make money on energy services afterwards.
That's awesome.
And so that's the like, and so what I realized though is what am I actually doing? I'm actually doing kind of this, like I'm kind of offering my services in the way BYD does, where it's like I've got all this underlying IP and manufacturing capability. It's not necessarily vertically integrated under me yet, but effectively I'm offering that. And I'll help you make an integrated product with the future's tech stack.
Yep.
And then every device and then we'll keep doing that until every device with a power cord is powered by Impulse.
Awesome. Let's end with what's the hardest thing you've overcome?
So what's the hardest thing I've overcome? This is a fun one. I think there's this product in getting this thing out, it was actually figuring out how to not pivot the business.
Just to get this thing that you actually wanted in the world.
No, it's not just, no, it's actually, I actually think what I was talking about with with kind of like how the business needs to be like indexing everything with the power cord basically. Yeah. But how do you do that without randomizing the business? How do you do it while it all makes sense as one story? And I think that was incredibly difficult. And it got us to the point of like, I was pretty confident that this product is like going to be fantastic. Like it just had the bones of something that's going to be special. But then how do you go from one thing to solving the distribution angle and getting people to believe
in that story,
believe in an integrated story.
Yeah.
Not that, you could go build like a power electronics supplier for the appliance industry as a separate, how can you make people believe in an integrated story? I think that was a incredibly hard challenge to put together. And it was something where like, I would describe it as there's what I would call a good idea, which is if you build high performance appliances, they have batteries inside because that makes them high performance. Once you install enough of these, you control the grid because you deployed enough battery storage. That's a great idea.
Yeah.
Because you'll actually transform the grid if you do it. The question is, how are you going to get that much distribution? And and I think a lot of people, investors, supporters of mine, et cetera, would largely question be like, okay, if I needed someone to tell me exactly how something like how to execute on some technical challenge, like I don't have a doubt that you could probably pull this out. We figure that out. But like, when does the sale convert?
Yeah.
And it's actually figuring out how to get from I am hardware rich and this product is really and product rich in a sense to actually getting to the other side, which frankly been more uncomfortable with, which is like, you need to be better at selling than you are at building in this market. And I think that's something that like, it just has to be true because
it's just not natural for you.
Well, no, it's not. It's actually something that like, I don't think is, I almost think like you think like Elon's a good example of this. Is like, he's better at selling than he is he's good at building. But like my point is he's better at selling because he needs to be able to raise the capital before he builds the thing.
Yeah. Yeah, that's why he's able to raise, $6 billion for XAI.
Because they know
Yeah.
what the outcome will be on the other side. So because the sale has been made. And so I think that's the like, and what I had to realize was like, okay, make sure there is a coherent big vision where it's like, okay, there will be distribution in this company is a $100 billion company.
Yep.
if you run this playbook. And I'm like, that took a second to really land. And I was like, I think we can do it with basically, if you can put if you can basically power most of these large devices that are going to people's homes, like
that's a big company.
That's a giant company. That's one of the biggest companies in the world.
Well, 150 or 140 million homes times like 3 or 4 appliances equals, massive market times $1,000 per appliance.
Yeah. You end up in a very, very good spot very quick. And by the way, our products are global. Like, it's a battery. It can charge off any voltage.
Yep.
So it's not just it's not just about the US as a TAM either. But basically but then it's like, okay, how do you actually confirm that there's a pulse on the demand side?
Yeah.
That's not just like a D2C play. And in some sense, it was like laying out the technical competence, the product excellence, like all that other stuff had to be there. But then it was like making sure that we basically built up all of that. And then we're like, okay, now
the proof points.
Now the proof point can happen. And so that's where we're really excited to be rolling out like announcements in that space, because it's going to pretty much back up being like, yeah, you went from your revenue, like production goes like this. And this is the case with hardware all the time. It's like, it's really hard to build the thing. And then when you turn it on, if it works,
then the ramp just looks crazy.
And you have really, really awesome moats, because it's like, okay, if it took 18 months for us to get certified for functional safety of our firmware and electrical system, and literally no other appliance vendors do that.
Yeah.
It's like, we're not like, there's not gonna be some other company coming in and trying to do that. Like, it's just not, it's like, what the barrier to entry is.
Yeah. And you've been working on this for over 4 years now.
And you can price that barrier to entry at, it's significant. So it's like, okay. And now and then the other piece was the number of iterations we built in the product. Like, we now have modules that we can stand behind for scale for other products. And so it's kind of this integrated thing of like, you had to do all that work to then be able to
reap the reward.
But then meandering through that storytelling exercise to be like, okay, here's the actual vision of where the scale lands. And it's much closer to NVIDIA, or where NVIDIA is, again, like powering every AI thing that exists, or BYD, like powering every electric thing that exists, than it is to
just an appliance
company where.
So you're basically like you're an energy company masquerading as an appliance company.
Yeah,
kind of thing.
Yeah, and I think, but then you're also an energy company, because again, once the battery is deployed, it is now an on-grid energy asset. So
yeah,
this story is a hard one to tell, and I think actually getting that across succinctly is something that I wouldn't describe myself as the best messenger of, because again, I think it's a big challenge, but it's incredibly simple to describe once you get there, because you're like, look, we built this awesome product. It's backed up by this platform, which Impulse Core, we're working on names and other stuff. And then that lands in everyone's existing distribution. They happen to distribute a bunch of batteries. Those have long lifetime value. And it's like, and that was still 5 too many steps, but you get the picture.